I'm Joe Beechem. I lead R&D for Nanostring, and I'm with Arutha Kulasinghe today from the University of Queensland, and we're at AACR, and what a day at AACR was today. And it was a great workshop we did together this morning, and we touched on so many things. I'd love to be able to just ask you a few questions to further talk about these things. One of the things that you're leading the way in spatial and cancer in many different aspects, and especially your theme of the importance of both RNA and protein for understanding whole slide images. Tell me the kinds of things you're learning these days, Arutha.
Great question, Joe. So we're trying to understand at a mechanistic level what's happening in the tissue. And so we're looking at whole sections from patients that have been treated with immunotherapy, pre-treatment tissues. And so we're looking at the whole transcriptome across these whole sections, and we map both the tumor cells and the immune cell components and the stroma, try to put these together to understand what are the driving mechanisms behind these. And then we pair that with whole tissue protein profiling to understand the cell phenotypes that are present in the tumor and the immune cells.
Yeah, amazing images. And one of the themes coming out of the research that you're working on has this link with metabolism and cancer and the importance of metabolism. And I find it really fascinating. Tell us about what you're finding out.
So we're finding that in patients that have a poor response to therapy, progressive disease, so they don't respond well to checkpoint inhibitor therapies, they have this increased glucose uptake specifically within the tumor cells. And it's interesting because it's not across all the cells, it's in certain pockets within the tumor cells. And so in the resistant cases, the glucose uptake is in those sort of tumor nests, whereas in the patients that are sensitive to therapy, the metabolic activation is really in the immune cells at that tumor immune boundary. And so we're trying to combine this metabolic functional data with the phenotype information to give us new insights into the tissue biology, driving both resistance and sensitivity to therapy.
Yeah. And one of the discoveries you've made has to do with this area. I don't think that a lot of people in the world may not know much about this ion channel regulated apoptosis, I guess, or cell death. And describe just a hint on how that works.
Absolutely. So in the patients that had this progressive phenotype in lung cancer, so a single agent immunotherapy versus standard of care, we could see that there was this increased activity of GPX1 and GPX4, which is driving this ferroptosis-like signaling through the tumor. And the really interesting bit about this is we could see it in every contrast. And all the immune cells, the T cells and the macrophages were on the periphery of the tumor, and they couldn't infiltrate the tumor in this instance. So we think it creates this ROS-enriched microenvironment that's preventing your T cells from entering the tumor.
Yeah, that's really an interesting finding. I can't wait to see more about that. And let's go into something that's sort of a really amazing thing that you were able to pull off. This is not a cancer-related thing. It's actually, you have samples that you're able to get from the Spanish flu, 1918. And maybe just tell the world a little bit how you got those samples and then the kind of measurements you're making on 100-year-old samples to understand what happened during the Spanish flu.
So we had this, the infectious disease community really excited when we did the COVID work, looking at the impact of COVID on the lungs, the heart, the brain, and the placenta, studies we've published recently. And Kirsty Short, who's one of the leading virologists in Australia, came to us and she was like, look, crazy idea. We've got these 100-year-old tissues in Germany, in museums, in archives. Would it be possible to investigate this using spatial? And I thought, for a second, what would Joe Beechem say to this? And I thought that was just, crazy idea. We have the right tech, and we've never pushed the boundaries. We've looked at tissues that are 10 years old before, and we've had robust data. And so we said, let's try it out. And at the time, the 570-plex was available for protein and the whole transcriptome. And so we had a student spend a year in Germany and Austria, mine through about 60 different sites and collect these tissues, bring them back to Australia. And we actually ran both the RNA and the protein assays. And we've been able to get really robust signal. And so the pathologists annotated these tissues so we could identify the areas of exudate, pneumonia, and so on within the tissues. And we ran both the RNA and protein assays on it. And the histology separated out the signal on the PCAs, and the protein data looks great. The RNA is a bit wobbly, but obviously in tissues that are this old, there are some really good samples. So we're trying to look at those specifically for the RNA content, but we're trying to understand from past diseases, what can we learn from them for future sort of pandemic preparedness?
Yeah, just amazing to be looking at Spanish flu samples at 570 plex proteins, all spatially resolved, and to see the information content you got coming out. And I like to end on just one that's fun. This is like you have such an imaginative way of trying to bring people from the outside into the world to help cure cancer. And tell us about this really fascinating thing you're doing with Xbox and Intel and cure cancer.
Yeah. So Microsoft came to see some of the work we do, and they were really excited by some of the spatial images, and Cure Cancer is a foundation in Australia that supports our research. And so Nikki Kinlock, who leads that initiative, we had this vision that we could bring together biotech, medicine, and breakthroughs like this. And so what we've done is we've taken spatial imagery and we've wrapped custom Xboxes to bring awareness to cancer research and funding early career researchers. And so it was launched by Microsoft yesterday globally, and it's a global auction to raise funds for vital cancer research.
Hey, so get your Xbox skinned with spatial patient samples. Not literally, of course, but with the images.
Absolutely.
Hey, thanks so much for taking the time out, Arutha, and I can't wait to see what kind of inventive stuff you're coming up with next.
Absolutely.
Thanks, Arutha.